In this example, we want to evaluate the definite integral from 0 to 1 of x squared times the quantity 1 plus 2x cubed to the fifth dx. In order to evaluate this integral, we can use a u substitution. If we let u be 1 plus 2x cubed, that's the inside function of our composition in the integrand, we see that du is going to be 6x squared dx. And we have x squared dx in our integrand, and so we can adjust this by dividing both sides by 6. So du over 6 is going to be x squared dx. And that we can substitute into our integral. In this particular example, we're going to change the limits of integration to be in terms of u. And so to do that, we're going to look at each of them separately. So I'll start with x equals 0, the lower limit, and we'll compute the appropriate value of u from that. And so using our equation that u is 1 plus 2x cubed, u is going to be 1 plus 2 times 0 cubed, which of course is going to be u equals 1. 1 plus 0, which is 1. The other limit is x equal 1, and so if we substitute that into our equation for u, we get u equals 1 plus 2 times 1 cubed, and that's 1 plus 2, which is 3. So we have an upper limit of u equals 3. Now, substituting all of these values into our given integral, we're going to have the integral from 1 to 3 of u to the fifth power times du over 6. And so we've substituted in both our values of u for the endpoints of our interval, going from 1 to 3 in terms of u. We've substituted du over 6 for the x squared dx part of the integrand, and we've substituted u for 1 plus 2x cubed. This then becomes 1/6 the integral from 1 to 3 of u to the fifth power du. And now we can use the Fundamental Theorem of Calculus to evaluate this integral. So we need an antiderivative of u to the fifth, which will be u to the sixth divided by 6. We're going to evaluate that from 1 to 3. And so we're going to end up getting 1/6 times the quantity here, 3 to the 6, which is 729 over 6, minus 1 to the 6th over 6th, which is 1/6. And so here, this becomes 1/6 times 728 over 6. And this simplifies to 182 over 9 when the fractional arithmetic is computed and the fraction is reduced to lowest terms. So our integral 0 to 1 of x squared times the quantity 1 plus 2x cubed to the fifth dx is 182 divided by 9.